Hello everyone, my name is Juliet Pontanares, and today we'll explore a strategic method to divide a state into optical regions using a divide and conquer algorithm. So, we'll break down the Python program that sorts key factors and determine the number of regions. Let's get started. Dividing a state efficiently requires us to consider multiple factors like demographics, it is the population distribution, geography, terrain and landscape, socioeconomics, which is the income, employment, and the standard of living. Next is behavioral. It is the cultural and social behavior. Lastly is governor's influence. It is the administrative control. Using merge sort, we can prioritize these factors and determine the ideal number of regions. So, before we dive into merge sort, let's first understand the divide and conquer approach that powers it. So, a divide and conquer algorithm follows these three steps. So, divide, split the problem into small sub-problems. Second is conquer, solve each sub-problem recursively. Last is combine. Merge the solution to get the final result. So this technique is efficient and is widely used in sorting, searching, and problem solving. And now, let's see how merge sort is uses this approach to rank our states factor in descending order. Understanding merge sort for factor ranking. So, first we use a merge sort algorithm to rank these factors in descending orders. Here's how it works. So, the list of factors is split into two halves. Each half is recursively sorted. The sorted halves are merged back in descending orders. Determining the number of regions. So, once the factors are ranked, we use a formula to determine the ideal number of regions. So, we normalize the sum of the top four factors, multiply the result by the government influence factor, and then use math cell to round off to the nearest integer. This ensures that the state is divided into well-balanced regions.
So we will now explore the depth number of regions code or part of the code. So here we will have the function. We'll have here the function, which is the number of regions. Inside these number of regions we have D, G, S, and B and V. This function calculates the number of regions based on 5 input factors, which we have the input validation. It ensures all inputs are between 0 and 100. If invalid, returns an error message. And and in the sorting values, we have input the inputs stores in a list which is like DGSBV, right? Then the corresponding labels are stored in labels and uses merge underscore sort underscore descending to sort values in descending order. While for the calculation of regions, compute the normalized sum using normalized equals d over 100 plus g over 100 plus s over 100 plus b over 100, which it multiplies the normalized sum by governor's value. Okay, it uses math that cell to round up the result. So for the output display, we have it printed the sorted factor ranking and also sorting time and calculation. Okay, and returns the maximum of one or the computed region count.
This code asks the user to enter 5 values representing different factors and then use a function called number of regions to calculate a result. First, we have a try block. This is important because it helps catch any errors that might occur if the user enters an invalid input. Here's what happens in this section. First, the program asks the user to enter five values. Second, each input is converted to an integer using int function. Third, if the user enters anything that is not a number, the program will detect an error. After collecting user input, we pass these values to the number of regions function, which calculate the final result. This means our function takes 5 input, does some calculation, and then return the number of regions. But what if the user enters something wrong? That's where the except block comes in. This part of the code makes sure that if the user enters a non-integer values, the program doesn't crash. Instead, it displays a helpful message.
So let's come now to test case number 3. Here we have the same from the test case previously, which is the test case number 1 and test case number 2. Here in test case number 3, we also have the user inputs, which the user enters the integers value from 0, ranging from 0 to 100. For 5 factors, we have the demographic, geography, socioeconomics, behavioral, and governor. Here in our example, we have the for the demographics we have 9, for geography we have 12, for behavioral rather socioeconomics we have 20, for behavioral we have 60, and for the governor we have 56. So after entering that, we will now go to the factor ranking, which the values are sorted in descending order and displayed. Here in our factor ranking, we have the behavioral 60, which is 60, the governor 56, socioeconomics, which is 20, and geography, which is 12, and demographic, which is 9. Then the next is it will has the processing time, which is its sorting time and calculation time are measured and printed. Here we have the for sorting time we have 0.000021 seconds. For the calculation time, we have 0.0000007 seconds. Then for the final output, it computed the number of regions which it also displayed. We're why which is we have here 15 number of regions.
The program begins by asking the user to enter scores for 5 different factors. Demographics 94, Geography 75, Socioeconomics 99, Behavioral 90, Governor 8. The program checks if each number is within the valid range of 0 to 10. The program checks if each entered number is within the valid range of 0 to 100. If a number is out of bounds, it prompts the user to enter a valid score. Each valid input is stored in a variable for later use. The program then arranges these scores in descending order to determine which factors have the highest influence. Sorting can be done with an array or a simple sorting algorithm. The program prints the factors in order of their scores, showing the highest ranked factor first and the lowest last. The factor ranking. Socioeconomics with 99, demographics 94, behavioral 90, geography 75, and governor 8. Finally, the program displays the total number of regions involved. In this case, it's 8 regions.
We enter 100 for demographics, 75 for geography, 50 for socioeconomics, 40 for behavioral, and 10 for governor. The program will print the ranking of these factors and will calculate the sum that will be divided by 100, giving us 7 regions. Now, let's see what happens when we enter an invalid input. Example, we enter A. The program will catches the error and give a friendly message instead of crashing.
The program starts by asking the user to enter scores for 5 different factors: demographics 71, socioeconomics 99, geography 59, behavioral 33, governor 18. The program checks if each entered number is within the valid range of 0 to 100. If a number is out of bounds, it should prompt the user to re-enter a valid score. Each valid input is stored in a variable for later use. The program then arranges these scores in descending order to determine which factors have the highest influence. Sorting can be done with an array or simple sorting algorithm. The program prints the factors in order of their scores, showing the highest rank factor first and the lowest last. The factor ranking are socioeconomics with 99, demographics 71, geography 59, behavioral 33, and governor 18. The program then displays the total number of regions involved. In this case, it's 12.